Good morning, students. Now in this class we are going to talk about stack operations. Okay. In previous class we have studied about what is a data structure and what are the different types of data structures, and at the same time what are the basic operations of data structures. And in the data structures, that is types. In the types we have linear and non-linear. In the linear we have studied about the stack, how we are going to represent the stack, and at the same time what are the representations, diagrammatic representations of stack, and at the same time how what happened when the stack is performing the push operation as well as pop operations. And we have studied about the basic operations, simple operations. No need to go in detail about the operations. Okay, if you see the operations, we have push operation, pop operation, and next one is status, traverse, is full, is empty. Okay, just now we are going to concentrate on the stack operations. See, among the operations of the stack, the major operations are push operation, pop operation, and at the same time status operation. Let us see the examples, that is one by one algorithms of a push operation, then pop operation, then next one is status operation. See, if you see the push operation, then what is a push operation? Here push operation is nothing but we are performing the insertion of a element, inserting a particular element into the stack. Okay, in the last class itself we have said that is if we performing the push operation, what will happen? Always top will become top plus 1. Before going to see the push operation, first of all we should check one condition, whether that particular stack is overflow or not. Okay, when the stack is overflow, we cannot performing the push operation. Okay, see, when if the stack is not overflow, that means if the stack is empty means if the stack is vacant. Okay, then only we are going to performing the push operation. Okay, here the some steps along with algorithms. So let us see. First one is in order to perform the push operation, first of all check if the stack is full. Okay, and second one is if the stack is full, produce an error message and exit. Okay, if the stack is full means we cannot performing the push operation, then automatically an error will occur. And third one is if the stack is not full, it means there is vacant position in order to performing the push operation. Then increments top to point next empty space. It is nothing but increment the top pointer, that is top equal to top plus 1. Again, next one is adds the data element to the stack location where top is pointing. Add means performing the push operation. Then fifth one is a return success. Okay, so these are the some few series of steps which are involving in the push operation of a stack. Whereas if you take the algorithm, see, first of all if I want to perform the push operation, okay, just now I have said now which condition we have to check, stack is full or not, means stack is overflow or not. See, what is the condition for stack overflow? If the first top greater than or equal to size, then what will happen? Stack overflow. Else, if the stack overflow, if it is stack overflow, now I cannot perform. Okay, if top greater than or equal to 0, if it is true, okay, what happens? Stack overflow. Else, then what will happen? I am going to performing the push operation. Okay, if whenever I am going to perform the push operation, then what will happen? Top will become top equal to top plus 1. Again, third step is I am going to represent the, after performing the push operation, I am going to represent the topmost element present in stack. Okay, that's I have written here stack of top equal to Ax. It means here after performing the push operation, the topmost element present in stack is X. Okay, so and stop. Okay, so this is the push operation. Then next one is pop operation. See, for the pop operation, first of all first condition, first we are going to check if the stack is empty or not. Here if you see the steps, first step is check if the stack is empty. Okay, if the stack is empty, then produce an error message. Why? Because if the stack is empty, if the stack is empty means no elements. If there is no elements, then why should we performing the pop operation? Okay, so that's why. So again, step 3 is if the stack is not empty, then automatically we are going to performing the pop operation. Okay, that is data element which is top is pointing. Okay, at the same time, whenever we are performing the pop operation, then what will happen? Decreases the value of top by 1, that is top equal to top minus 1. So fifth one is return success. Okay, so these steps only we are going to mention in the algorithm form. Okay, see here, first of all, if we want to performing the pop operation, what is the condition for stack underflow? Top equal to 0 or minus 1. Okay, less than 1 means 0 only. Okay, top equal to minus 1 or 1, then what will happen? Stack is underflow. Else, okay, if the condition is true, stack underflow. Okay, else, then what will happen? I am going to perform the pop operation. Whenever performing the pop operation, top will become top minus 1. Okay, top equal to top minus 1. Okay, I am going, next third step is I am going to return the topmost element present on stack. Okay, just I am going to return like this, return stack of top. It means I am going to return the topmost element present on stack. Okay, so this is the algorithm for pop operation. Next one, algorithm for status. Before going to see, let us see some conditions, that is what is a stack overflow. Okay, so just now I have said na, stack overflow is nothing but pushing the element onto the stack which is already filled. It is nothing but stack overflow. How to check the stack is full or not? If stack of top equal to maximum size, then it is, we can call it as a stack is full. Next, one more thing is before removing or before performing the pop operation, we should ensure that stack is not empty. Removing the element from the stack leads to the problem of underflow. Okay, how to check? If top stack of top equal to minus 1, then we can say stack is empty now. So just now we have checked these two conditions in the push and pop operations only. Then next one is status operation. See, status means just I have said in the basic operations, status means what is the percentage of free space available in the stack. See, I have said, for example, if the size of the stack is 6, among the 6, 3 elements are stored. Okay, that means 50% of the stack is full. Okay, if 3 elements, for the 3 elements we have vacant position, then status is nothing but 50% of the free space available. Okay, of course, if you know the status, first of all we will check the stack is empty or full. Okay, first of all we have to check stack is empty. If not, stack is full. Okay, if not, only I am going to go for stack is stack status condition. Okay, so here first of all I am going to check the stack empty condition. If top less than 1, then we can say stack is empty. Then else, again I am going to check the stack full. If top greater than or equal to size, what will happen? Stack full. Okay, if the first case false, second case also false. Okay, then what will happen? Third case. Okay, that is, here there is one formula how we are going to calculate the free is free equal to size minus top by size into 100. Okay, that free only we are going to print percentage of free stack is free. Okay, here free equal to size minus top by size into 100. Here size is nothing but total number of elements present in the maximum number of elements present in the size array, sorry, stack. Here top means topmost element present into the stack. Okay, it is the formula for calculating the free. Here into 100 means this status will represent in the form of percentages, so we should multiply with 100. Okay, so it is the algorithm for status. Okay, push algorithm, pop algorithm and status algorithm. Then I will go for stack, some definitions, that is stack push, overflow, pop and underflow. Here stack push means process of inserting a new element to the top of the stack is known as push operation. Overflow means we are going to attempting the inserting of a new element in the already full stack, then automatically it leads to a stack overflow condition. Again, what is a pop? Top stack pop means removing element from the top. We can call it as a pop operation. Underflow means we are going to performing the deletion operation and deletion of an element from the already empty stack. Then we can call it as a stack underflow. Okay. Then if you see the applications of stack, that is stack computer science related applications. First one is pile of books. Okay, see here some books are there. If you want to performing the push operation and pop operation, it should be only one end only. Okay, that is insertion and deletion we are going to performing at the only one end. Of course, the topmost element we are going to represent it by the top. Okay, and one more thing is one more computer science related application is reverse a string. Okay, string reverse. Okay, see here it is a simple application of stack. Okay, to reverse a string, the characters of string are pushed onto the stack one by one as the string is read from left to right. To reverse the string, REVE or SC, the string is read from left to right and its characters are pushed. Okay, the thing is I'm going to take the string is reverse REVE or SC. Okay, so if we have performed the push operation, first I am going to push the R, then E, V, E, R, S, E. Okay, here now the topmost element is E. If you performing the pop operation, then what is the first element which is going to be removed? Pop E. Okay, that is E, then S, then R, then E, then V, then E, then R. Okay, like no. So it is a stack. Okay, if I performing the push R, E, V, R, S, C, after performing the pop, the reverse string is E, S, R, E, V, E, R. Okay, so it is one of the computer science related applications of stack. So next one is recursive function. Okay, it is also a very good example for stack, that is function. Here factorial of a given number. Okay, summation of positive integer can be implemented by recursive function, and the function are stored in a stack in order to maintain a sequence of summation. When a function is called within a function, then the previous function is stored in a stack with its local variables. Okay, for example, sum of 5 is sum plus that is 5 plus sum of 4. Okay, then next one is 5 plus 4 plus sum of 3, then 5 plus 4 plus 3 plus sum of 2. Again same, 5 plus 4 plus 3 plus 2 plus sum of 1. Again 5 plus 4 plus 3 plus 2 plus 1 plus sum of 0. Okay, like this. Okay, first of all sum of 5, then sum of 4, sum of 3, sum of 2, sum of 1. Okay, so this is also one of the examples for stack. Okay, the next one is a palindrome. Generally palindrome is nothing but it is a word, or we can say a parse or number or other sequence of characters which reads the same backward and forward. Okay, so if we take one character, if I reverse that one, we will get the same thing. Okay, for example, A, B, C, D, C, B, A is a palindrome. Why? Because if I reverse this one, again same I am going to get one same only, that is A, B, C, D, C, B, A. Okay, again F, G, H, H, G, F, it is a palindrome. Okay, if I reverse this one, I am going to get the same string only. We can call it as a palindrome. Okay, for example, one more thing is M, A, D, A, M. Okay, if I reverse, I am going to get the same only. Okay, it is one of the palindrome. In order to implement the palindrome, we are going to use the same concept, that is stack. Okay, here the palindrome word is civic, that is CIVIC. If I performing the push operation, the first one is C, second one is I, third one is V, fourth one is I, again last one is C. If I performing the pop operation, again I am going to get the same one. Okay, after pushing and popping, civic would remains unchanged. Okay, why? Because it is a palindrome. Okay, so it is one of the applications of palindrome. Okay, then next one is towers of Hanai. Okay, so what is a towers of Hanai? So it is one of the puzzle. We can say it is a puzzle, which is one of the applications of stack. It is a mathematical puzzle Here we have, in this puzzle we have three towers. We have three towers, or we have three rods, or we can say three pegs, and a number of discs of different sizes which can slide into any tower. There is a number of discs with a different size. The sizes are large, medium and small. We can say large, medium and small. Here the puzzle will starts with the disc on one tower in ascending order of size. Ascending order means large, medium, small. The smallest at the top making a conical shape. Okay, the thing is, I am going to keep large, medium and small. Okay, the main objective, the main agenda of the puzzle is to move the entire stack of discs on another tower with satisfying the rules. Okay, totally we have three towers are there. Okay, in the first tower I have three discs, that is large, small, large, medium, small. The thing is, I am going to move these three discs with another, that is, for example, ABC. I am going to name as ABC three towers. In the A tower I have three discs of size large, medium and small. I have to move the three discs from A to C with the conditions, within the satisfying the following conditions. Okay, the conditions is only one disc can be moved at a time. Okay, at a time, whenever we are going to performing the moving of discs, at a time only one disc should be moved. And next one is, each move consists of taking the upper disc from one to the lower and sliding it another tower on the top of the other disc that may already to be present on the tower. This is the second rule. And the third one is, no disc can be placed on the top of the smaller disc. Here the thing is, we should not keep large disc on medium, or small disc we should not keep medium disc on smaller. Okay. So by seeing these rules, we are going to performing the this puzzle. Here three towers is there now. We are going to move the three discs from A to C. For that one only, I am going to use B tower as a temporary tower, or it is a auxiliary tower. Okay, in order to move the disc, I am going to use the tower B as temporary. Okay, so that's why I am going to take three towers. Okay, here if you see, here this is the source, here auxiliary is the, it is the temporary, so it is the destination. Okay, here large disk, 3 is the large disk, 2 is the medium, 1 is the small. Okay, the same thing should be kept in the destination disk, destination tower. Okay, by satisfying the rules. Okay, here it is a valid move. Here valid means we should keep smaller disk on top, large. That means here large, after large, on the large we have medium. Okay, here as a invalid move means here medium is there now, after on the medium we should not keep large. Okay, so it is the invalid. So it is the puzzle. So if you see here, here first one is the original configuration, that is large, medium, again small. Here in the first move I should I should move the that is small disk onto the C. Okay, here ABC, assume that ABC, C. Again in the second move I should move the second, that is medium disk onto the B, that is auxiliary. Okay, again in the third move I should keep the small, that is small disk onto the medium disk, which are in the auxiliary disk, auxiliary tower. Okay, then again in the fourth move I should move the large disk from source to destination. Okay, why? Because in the destination disk there is no disk, in the destination tower there is no disk. Okay, then next fifth move, what will happen? I should move the actually after fourth move. Okay, we have two disks on auxiliary, it means B tower. that is medium and small. Okay, now fifth move, what I am going to do is I am going to move the small disk from auxiliary to source, that is A. Okay, so at the completion of the uh, fifth move, what will happen? There is three disks on three towers. Okay, in the destination tower, large disk. In the auxiliary tower, we have a medium. Again, in the source, we have small. Okay, the thing is, we should keep large disk on medium, large disk and medium and small. Okay, so that's why in the sixth move I am going to performing the moving of medium disk from auxiliary to destination. Okay, in the seventh move I am going to performing the moving of small disk from source to destination. Okay, here after completion of the seventh moves, okay, what we will get is that is our objective only. That is, initially there is a source. In this source we have large disk, medium disk and small disk. At the completion of the seventh move, in the destination disk tower, in the destination tower we have same thing, that is large, medium and small. Okay, so in order to performing the towers of Hanai, totally we have 7 moves. Okay, so in this way we are going to performing the towers of Hanai mathematical puzzle. So next we will see some of the differences between arrays and stack. Generally stack is a collection of items. At the same time it is a dynamic object whose size is constantly changing as the items are pushed and popped. At the same time, stack is contain different data types, and the stack is also declared as a structure containing a array to hold the element of stack and an integer to indicate the current stack top within the array. Whereas if you take the array is the ordered collection of items. At the same time it is a static object, that is number of items is fixed and is assigned by the declaration of the array. It contains the same data types. Okay, it does not contain the different data types, it has the same data types. Array can be home of stack, that is array can be declared large enough of maximum size of the stack. Okay, so this is the difference between stack and array. Okay, thank you.